This map shows the version of the solar system we all learn in school. 4 small, rocky planets sit tightly packed around the Sun, while 4 massive gas and ice giants sweep through nested, perfectly circular orbits further out. It looks peaceful. It looks settled. But in 1995, our telescopes finally allowed us to peer into the planetary neighborhoods of other stars. We expected to find copies of our own tidy system. Instead, we found that a structure like ours is incredibly rare. The data from these distant star systems shows us that planetary arrangements are usually chaotic. Planets of all sizes are scattered randomly throughout their systems, constantly crossing paths and swinging through highly irregular, eccentric orbits. By observing thousands of other stars at various stages of their life cycles, with instruments like the Hubble Space Telescope, we have gathered the data needed to understand how planetary systems actually take shape. Applying that data back home reveals a surprising truth. The predictable circular arrangement of our planets is a deceptive illusion. Our solar system is a survivor of immense cosmic violence. If we look closely at the physical scars left behind, we can reconstruct what happened. 4.5 billion years ago, there was no sun. There was only a massive, freezing cloud of gas and dust floating through space. A nearby supernova sent a shockwave that slammed into the gas, forcing it to collapse and pull its contents into a massive spinning vortex. At the very center of this vortex, the friction and pressure ignited an infant star, a T Tauri star, surrounded by an accretion disk of debris. The moment this young sun ignited, a strict timer started. As the star burned, its powerful outward radiation began blowing the surrounding debris into deep space. Any planet that was going to form had to gather its building blocks before that material was completely cleared away, a strict window of only about 10 million years. Look at this temperature map of the early solar system. Close to the sun, the intense heat vaporized elements like water and methane, but right around 5 astronomical units out, space was cold enough for those volatile elements to freeze into solid ice. This boundary is the snow line. Ice provides enormous building material, so the first planetary core coalesced exactly at this boundary, rapidly sweeping up millions of tons of frozen dust. Growing incredibly heavy, its gravity began siphoning hydrogen and helium gas directly from the disk. In just a few million years, it ballooned into Jupiter, dwarfing everything else. Surviving the solar system's 10-million-year deadline was a brutal race to accumulate mass. And because Jupiter won that race so decisively, its sheer gravitational weight set the stage for a period of extreme physical disruption. As Jupiter consumed vast amounts of the surrounding dust and gas, the shifting mass dragged the giant planet slightly inward. It spiraled toward the Sun, plowing through the disk and starving its newly forming sibling, Saturn, of the materials it needed to reach the same size. We can see the physical scars of this resource starvation further out. Uranus and Neptune orbit in the deep freeze of the outer solar system. But there simply wasn't enough dust that far away for them to have grown to their current sizes before the 10-million-year window closed. They must have formed closer to the Sun, wedged near Jupiter and Saturn, before being exiled. Here is the mechanism that caused that exile. About 500 million years after they formed, Jupiter and Saturn fell into a 2-to-1 orbital resonance. For every single orbit Saturn completed, Jupiter completed exactly 2. This synchronized alignment acted like a massive gravitational slingshot. The combined, repeating pull of the 2 largest planets kicked Uranus and Neptune violently outward, deep into the outer solar system. When Neptune was flung outward, it plowed directly into a dense band of primordial ice chunks known as the Kuiper Belt. Trillions of massive icy comets and asteroids were scattered. While some were ejected into interstellar space, countless others were hurled directly towards the Sun, resulting in a 300-million-year period of relentless impacts across the inner rocky planets, an event we call the Late Heavy Bombardment. The chaotic migration of the gas giants caused absolute devastation, but it also served as an accidental delivery system. Those trillions of scattered comets were carrying something essential to the rocky inner worlds. The icy comets that pounded the inner solar system during the Late Heavy Bombardment were packed with frozen water. Upon impacting the rocky surfaces, the ice instantly vaporized, thickening the atmospheres. Over thousands of years, those inner planets cooled, allowing the vapor to condense and fall as endless rain, eventually filling massive basins with liquid water. We think of Earth as the sole water world of our system, but the physics of this massive comet delivery actually created 3 distinct blue planets simultaneously. Mars, Venus, and Earth all possessed vast oceans of liquid water on their surfaces. The divergence between these 3 worlds came down to physical scale. Mars is significantly smaller than Earth, meaning its internal core cooled down rapidly. Without a molten, swirling core, the planet's protective magnetic field switched off. Solar radiation then freely bombarded the planet, stripping away its atmosphere and causing its oceans to evaporate into space. Venus faced a different threat. It had the mass to maintain an active core, but as the sun naturally aged, it burned hotter and brighter. The rising temperatures triggered a runaway greenhouse effect. The atmosphere thickened, trapping immense heat, and Venus's oceans simply boiled away. Earth sits perfectly balanced between these 2 extremes. It is large enough to sustain the internal geological activity required to power a magnetic shield, and it rests at the exact right distance from the sun to keep its climate temperate for billions of years. The predictable orbits and perfect conditions we experience today are not the default state of the cosmos. They are the fragile remnants of millions of years of violent planetary migration and cosmic collisions. And as the sun continues to age and expand, even this temporary oasis will